Okay, so my name is Sari Anderson. I'm a PhD student in health policy and management, and I'm the TA for HPM 785 this spring 2018. So today I'm going to be showing you how to use Crystal Ball to define assumptions and distributions for the parameters in your model, define the outcomes that you want to forecast, run a PSA, and view and interpret the results of your simulation. So I have here a model that I built in HPM 772 and 785. It's looking at whether it's cost effective to screen all new mothers for postpartum depression or whether we should continue doing things the current way where just some women are screened and most women have to kind of self-report if they want to get treatment for postpartum depression. So what that means is that my model has two alternatives, usual care and the intervention. So the intervention would be screening and usual care is kind of what we're doing now. I'm going to be defining a couple of things that I want to forecast. So those are kind of the outcomes that I will want to have data for to do kind of calculations later. So I'm going to be forecasting all of the QALYs here. So the total QALYs for usual care, the total QALYs for the intervention, and the incremental QALYs. I'm also going to be forecasting the total costs for each of the alternatives and the incremental costs. And then last of all, I'm going to be forecasting the cost effectiveness ratio. So I'm going to need all those numbers to calculate my ICERs, my SEAC, and my net monetary benefits. So I had already gone through, as I said, in HPM 785 and done a PSA on this model before. So a lot of these, wherever you see it highlighted in green, that means that that variable already has a distribution applied to it in Crystal Ball. But I removed the distributions from a couple of variables just to show you how to do that. So we'll be walking through that as well. So let's get started by defining our forecasts. So let's see. So I'm going to start with the QALYs. So to define a forecast, you come up here to this button, click on that. You give it a descriptive name. So I'm going to say QALYs for usual care, and you tell it what the units are. Then you hit OK, and now it'll be highlighted in blue. That's how you know that you did this correctly and that it went through. So I'm going to do the same thing for all of these that I listed before. So this is going to take me a minute or two, but it should not take too long. Sorry that you have to watch me type for a bit. So like I said, I'm doing all of the different kind of QALY outcomes. So those are all of the kind of effect or benefit outcomes. And now I'm doing all of the costs. Total cost of the intervention. Also, apologies if my voice is a little gravelly. I am getting over a cold. Okay, and last of all, we're going to do the cost effectiveness ratio. Okay, so these are all our forecasts. We're set there. We could run the model without defining all of the kind of assumptions or parameterizing the variables, but you would really just get one number over and over again because it wouldn't have any variation in it. So that's why we want to add on kind of assumptions or assign distributions to these variables. So I'm going to be doing that for two of these just to kind of show you. The first one is going to be this prevalence of postpartum psychosis variable. For this one, the literature didn't have a lot to go on, so I ended up choosing a uniform distribution because we really weren't sure kind of what the average value of this might be, where in this range it might fall. We just kind of had these three numbers, 0.002%, 2%, and 3% of the population having postpartum psychosis. So to assign the distribution to this variable, I'm going to go up here to this define assumption button. I'm going to click on uniform. You'll get a little pop-up window. I think it's really good. I think it's important to refer to actual cells in the spreadsheet so that you're kind of showing your work. So be sure to kind of do that and not just type in numbers. So we hit OK, and it turned bright green, which means that we defined that assumption properly. Now I'm going to scroll down here. The other one I wanted to do is this discontinued treatment variable. So because this is a probability, we'd like it to have a beta distribution, so between 0 and 1. For this variable, we're lucky enough to have a paper that told us how many women discontinued treatment and how many women were in the study total. So we know that if our event is discontinuing treatment, 65 women had that event out of 201 women. So we can calculate our kind of alpha and beta parameters for this beta distribution. So I'm going to go up here again to define assumption. Beta doesn't appear in this for me, so I'm going to go to distribution gallery and click on all, and beta shows up in here. So I'm going to set the minimum to 0, the max to 1. I always do this for beta's distributions for probabilities because those are the kind of hard mins and max for these. For alpha, I'm setting that to 65 because that's the number of women who had the event. And then the number of women without the event is 201 minus 65, or 136. So we hit OK. It turns green. That means we're done. That means that now we can start actually running our PSA. So to do that, you can change the run preferences up here and the number of trials. I usually don't change anything with these. It works fine for me. So I'm going to hit start. Just to warn you, a bunch of boxes are going to start popping up, so be prepared. Okay, so they popped up on my other screen. I'm going to pull them up. Basically, I got a box for every light blue cell that there is in my model, which means that there are like 8 boxes hiding down here. So I've dragged up a few of them so that you can see, but in general, I don't find these charts particularly useful. That may just be me. They do show you the range of values. You can look at these and see that if there's no variation in one of these, that's probably not a good sign. Probably you've messed something up in your model. So I usually do check them just to make sure that there is some kind of variation in the numbers. I wouldn't want to see them all looking exactly the same. So we've got a bit of variation. It also shows you this kind of range, which is interesting. So if you pull in these little arrows, it'll tell you the kind of percent of observations that fall within those two ranges. I would not consider this like a 95% confidence interval, just because I think there are probably some more official calculations that you can do for something like that, but this is a good tool if you want to see kind of what percentage of observations fall within a certain range. Okay, so I'm gonna just close a bunch of these windows because, like I said, I'm not really interested in them. We've got our little control panel down here that tells us how many trials we ran. It lets us kind of step back slowly, stop if it was taking a long time to run, and we can run it again. The last thing that I'm going to do is show you how to extract data to calculate your ICERs, your CACs, your net monetary benefits. To do that, you would hit extract data. And for calculating the things that we care about, you're going to want the trial values for all of your forecasts that we did and none of the assumptions, and then hit OK. And what you should see is a bunch of trial values. So this is each of your 1,000 trials, and then what kind of numbers you got out for your cost effectiveness ratio, incremental costs, QALYs, etc. So you can plug these into spreadsheets to calculate your CACs or produce an ICER or produce your net monetary benefits. I usually save these separately so that I can refer to them later. Great, so hopefully this covered everything that you're interested in for now. Definitely reach out to the professor or your TA if you have more questions. Thanks for watching.